Welcome everyone. Today we have this webinar about cloud compliance by design. I'm going to be talking about how to reduce risk, cut costs, and ship faster using infrastructure as code as the main topic. My name is Mariano Dorado. I'm a senior security engineer at Svitla System. Svitla is a global digital solutions company with over 20 years of industry experience. We have over 1,000 top tech talents. We are in 13 global locations. We have been in the industry for over 20 years now. We have completed 5,000 projects related to technology and staff augmentation. So for the agenda today, we are going to be covering these topics. So we're going to be seeing why cloud misconfigurations cost more than you think. We'll see the cost of waiting, of adopting infrastructure as code, and applying security to it. We'll see how with infrastructure as code and a tool called Checkov, which is a Python tool, companies can align with compliance standards. We'll then go to a live demo. I'll show in a GitHub flow how to use this tool, and then how to implement it in a automated fashion in CI/CD pipelines. And we'll see the benefits of it on the time save, how we can reduce cost, and how we can earn trust in our company. So to start off, I'll talk about why cloud misconfiguration cost more than you think. And we can see clearly in this image, actually, most of security incidents in these years have been 80%, which is a top number, a high number, related to cloud misconfigurations. We can see in the image that 88% of these security breaches are due to human error. That means that humans actually don't implement good security to their solutions in the cloud. As you can see, it's a top priority for companies. It's been in 2023, and it's been growing over these years. As we can see in this image, I will describe the impact of cloud misconfiguration. It's not just as a major cybersecurity threat, but having a cloud misconfiguration can lead to loss of competitive edge, data breaches, money being lost for paying fines in the industry standards, and of course, downtime for having systems comprised. As we can see over here, actually cost due to security or data breaches are quite high. They're high on, I mean, even to big companies. For small companies would mean bankruptcy. And besides security fine, money fines and regulatory fines, there comes with a data breach, customer trust loss, and remediation costs. So in a typical impact, we start off with a security misconfiguration, which an attacker discovers, and then he proceeds to exploit, causing either operational downtime or data breaches, making that to companies a huge headache due to financial losses, and later on, reputational damage comes to companies having loss of customers. So we'll now see the cost of waiting for adopting a secure infrastructure as code. And I proposed I will go on and I'll go on over two case studies. First one is Capital One, which had a breach where an attacker got into a EC2 instance in Amazon due to a misconfigured firewall. And since that EC2 instance had full permissions, uh, the hacker was able to list all the S3 buckets in the company, and he filtered the information in the web. So what happened there? So basically, Capital One said they had NIST cybersecurity frameworks. Also, they were FFIEC compliant, and they claim to be all these SOCs. They Graham Leeson, the GLDA, which is for financial regulations, and the PPDA for Canada. So they said they had these controls, which they had it in paper, but they were not truly, well implemented. So it's not a lack of precision in these controls, but it's a lack of how cybersecurity developers implemented those. As you can see, these situations had over excessive permissions. WAF rules didn't block the attacker. There was no monitoring alerts. And well, as you can see, also lack of detection for this data loss. Then we have the T-Mobile study, which they had a huge security breach since an attacker brute forced into a router that was publicly accessible. This attacker, once once he or she got into the router, it started moving laterally in the network since the network didn't have segmentation. And the company didn't know they were breached until a security firm wrote an email to T-Mobile, and they were like, okay, so here are your users' data, so you will be breached. And once that went confirmed by T-Mobile, it was late, and where there were 40 million current former and customers affected. And this information was names, social security numbers, driver's license numbers. So after that, T-Mobile lost a lot of money since they had to settlement. They had this class action settlement that went ahead on 2022. And as you can see, the total cost went over $500 million for also they pay to the Anti-Communications Commission in 2024. So huge amount of loss of money. So what happened here? So as you can see in this image, and as I mentioned before, brute forcing SSH, it's related to access control. For example, network segmentation is related to a flat architecture, which is something we don't want in security. There were no alerts for data coming on and going through Tor and VPN services. That's what the hacker used to hide himself. And there was no data protection since the sensitive PAI data was not encrypted. So even if the attacker got into it and saw the data, he couldn't. If data it should have been encrypted for him not to see it. So we'll see how with infrastructure as code, we can follow best practices. As you can see in this slide, having infrastructure as code in your company can help you have a version control of your software. You can have automated testing, change management. You can automate infrastructure, and you can apply it in the whole life cycle of your software, from planning to retiring your software. Just having everything as code, which is policy as code, compliance as code. You can apply cloud security standards as code, and we see how Checkov can help us with that. So when it comes to the best practices on developing software in DevOps, we can see that we have a broad scope of security best practices. At this webinar, we're going to be focusing on the testing part of these best practices, since we're going to see how with this tool called Checkov for Terraform, which is mostly used for Terraform, companies can scan their code and have insights about their security postures. We are looking to have a context in this webinar where companies actually need to be aligned with any of these, like one or more of these frameworks. So we have the GDPR, that's a European Union standard for its to protect data. We have SOC 2, which is a security auditing compliant framework. The HIPAA, which is for medical companies. PCI for data, for credit card data. We have the ISO 27001, that's for security also. And we have the CCPA, which is like the GDPR, but for United States, for California. So in a normal workflow, we'll push our code to GitHub. With GitHub Actions, using Checkov, we can scan our Terraform code. We can scan also CloudFormation, ARM, Kubernetes YAMLs, and Docker files. And once we scan that code, we can apply policies to let code go into production or not based on policies that we define as a company. So this tool can map its reports to SOC 2, for example, where SOC 2, I included some points they check in their auditing form, which is S3 buckets, for example, must have encryption and they must be private. The HIPAA requires login and encryption of patient data. This is just a few examples. PCI DSS requires that databases must be encrypted and there should be used only private networks for card data. For what's ISO 27001, audit login and IAM boundaries they ask companies to have. And the GDPR or CCPA, they care a lot about data retention, geo-restriction, and access control. So here's a technical example of a unsecured Terraform file, which I intended to create a bad S3 bucket, which is, for example, public, a security group with worldwide SSH access, which is something that's insecure, and a DB instance, a database instance that's public. So if we go ahead and run a Checkov on it, we'll see a output of warnings. That's, for example, for the buckets, it will tell us that actually bucket has to have login enabled, which is a feature that Checkov looks for. Besides being a public bucket, it has to be private. Well, it would tell us that the security group shouldn't be worldwide to accept connections. And well, for the database, it doesn't have to be public. For the HIPAA and the PCI DSS, as you can see in the image, there's the frameworks recommendations for each topic. So now I wanted to go on and show a little demo on this, where we're going to see in a few, I'll show you a repository I have, which is a compliance demo, I named it, which I have a failing example of infrastructure being unsecurely programmed, which, for example, I create an S3 bucket that's unsecure, since it violates, as you can see, you will later on have access to this repository to see in a more detailed fashion what I'm talking about. But it's basically an insecure definition of infrastructure, which is going to be deployed, which is intended to be deployed in Amazon Web Services. We have an EC2 instance and a database. This is something basic for me to show this, just to show this concept. And then we have a passing example of infrastructure being properly defined with S3 buckets, for example, being having versioning, for example, or being encrypted, being private, having IAM best permissions, least privileged permissions, and so on. So that's a database and security groups resources. So as you can see over here, so this is my terminal. So if I go ahead and run a Checkov on the failing example and I hit enter, we should see a output which actually tells us that our code is in compliance. So we can see that we didn't pass any check actually, and well, just let me check this. Okay, this is on secrets. So for the whole infrastructure, we'll see that actually all of these checks are failed checks. So you see we have many failed checks. Each check mapped to a documentation that tell us, that's for Terraform, that tells us from Prisma Cloud to tell us how to fix it. And at the beginning, so see many fail actually checks. If I continue going to the top, there's some checks that we passed, but depending on our requirements for our company, we may want to pass all checks. So this is not something that we want. So if I go ahead and just check for the passing example, which is a secure configuration, hit enter, and we will see that in this case, we have passed every check that we want to actually pass for our infrastructure being deployed. So as you can see, there's 63 checks, these checks are on Terraform standard checks, but Checkov allows you to program your own policies, which it's quite good since you can customize your security based on your company needs. So if you ask me, okay, so how do I integrate this with GitHub? It's quite simple since it can be done with a GitHub Actions workflow. So as you can see, I defined here a little YAML file to actually make Checkov run on a pipeline. It actually checks on the failing example and the passing example. So if I go ahead and make a little change, to a file just to push code to production and show the output, we'll just see that if I push this to GitHub, I should get a warning from GitHub coming from Checkov that is going to tell me that infrastructure is not secure for the failing example being pushed to production. So if I go ahead and go to my repository, I will see over here that a check is running, which is pending. So if I come over here and I go to details, you will see the step-by-step of what GitHub is doing with Checkov. Right now, it's installing Checkov to see the latest version of what it's happening behind the scenes and to actually check if our code went to production or not. Just go to the code example, and over here, we should see either a cross, meaning like the code isn't compliant, or we should see a check that our code went well into production. So still pending, it should take as time it took. 40 something seconds. So as you can see here, all checks have failed. So if we go to the details, what's the code being pushed to production got canceled, and the insecure code didn't went to production. So we can see the cross over here. And for example, if I make a little change over here, and I, for example, paste this passing example, which is the secure infrastructure I defined. It's that we went ahead and saw in the example before. If I go ahead and just copy this and go ahead and paste it in the failing example, which is now a passing example. If I go ahead and I just commit this and push it, we'll see that now it's going to be another check going on, which is over here. So you can see that there's the code being checked. If you go ahead and see the details, we see that this is running as we defined in the workflow of Checkov, which is signing Checkov at the moment, and it will check these two failing and passing examples, which are the two passing examples. So if we go ahead and see the code, we see that it's still pending. It will take a few seconds. It should take at least a few seconds. The idea is that we should see a tick over here, just like a check of this code actually being compliant, since we have the two passing examples in the two folders. So as we can see over here, so it's a passing example. So if we go to see code on tab, we can see that our code actually went well, since it's a secure definition of code. And we can see that it got completed successfully. So that's a little bit like that was the demo. Back to our presentation. I went to the top. I'll just go ahead and skip this fast to demo slide. A few slides more. So at this time, we have seen this, how to automate these policy enforcements in CI/CD pipelines, which this is basically how it works. When we open a pull request, we'll push it to GitHub. We have GitHub actions running with Checkov in it. Checkov will tell us if our code is secure or not. Based on that, it will block our code or let it pass, and we'll see an output with like the failing or passing information, what the policy says about this check and how to fix it following the documentation link. So using this tool, which is quite simple, it's open source, we are going to save time automating scanning of code in CI/CD pipelines. We can shift to the left security, actually checking our code before it goes into production, even before, like, we can check it from design actually, and it's faster onboarding to security in our software. We are going to avoid regulatory fines if we actually apply Checkov in the right way, programming the right policies and applying best principles. We'll also reduce breach remediation cost and minimize downtime. So it's easy to apply this from the beginning, that fix it in production. Then that comes with trust earned, since it demonstrates companies have a security maturity, and these companies can also apply they can support certification and auditing, and it builds also internal confidence to teams. So that's it for the webinar. if you have any questions, please let us know. So thank you all for joining, and have a great day.